like to introduce Mao. He will be presenting pyGNMI and using ChatGPT to troubleshoot EVPN Datacenter Fabrics. So I'm looking at using layer 2 as opposed to going to layer 3 to manage and troubleshoot those networks. Mao is a network automation consulting engineer, so he's a subject matter expert at Nokia, based in Texas. This is Mao's 4th time presenting at NANOG. He was at NANOG in Atlanta last month, or last quarter, and did a tutorial on Kubernetes 101 for network professionals in Atlanta. And this, again, is going to be based on Kubernetes containers for this work. Welcome back, Mao, and it's a pleasure to have you here with us today. One thing regarding questions, I know it's going to go through a lot of technical detail as part of this, but if we could hold the questions until the end, there'll be plenty of time at the end for you to be able to ask all the questions regarding the content that he's going to provide us on this session. So thank you so much. Mao, thank you.
Thank you. Thank you, Stephen, for the introduction. And hi, everyone. You can call me Mao. My real name is Mauricio Rojas, but everybody call me Mao because there's too many Mauricios in Nokia right now. Then it's easy for everybody to identify myself in the company. I'm not an expert in Python. Okay, I'm just going to talk about my experience. I would say that I know something about the basics of Python, but I have to say ChatGPT actually was very helpful, giving me the best practices and helping me to make my applications for this tutorial better. I got many best practices directly from ChatGPT. It was like to have my own Python expert next to me and asking all the questions that I needed to create those applications. Then the abstract of this is, and I should have added also GNMIc as part of the title, but I wanted to keep it short, you know. And but I'm gonna also show GNMIc with Go Templates, and I'm gonna show something that I developed for this tutorial with pyGNMI. But the main point of this presentation is to tell you that you don't need to be proficient in Python to create any application. The session before this one was about BGP. They were talking about communities and everything. This is way more complex than actually do any application in Python. Then, and now with the help that you can have with applications like ChatGPT, it should be even easier to try to create your own applications to troubleshoot any of your network. And this is why I'm saying you don't need real skills in Python in order to start using pyGNMI, creating your applications to troubleshoot anything in your network. Then over this tutorial, I'm going to talk about how I created this lab for this tutorial with containerlab. If you are not familiar with containerlab, this is an open source project that is going to help you to create your own labs. I'm going to talk a little more about it later. In this tutorial, I'm using spine leaf plus a border leaf architecture design, and I'm using EVPN-VXLAN, layer 2 and layer 3. And I'm using eBGP for the underlay. Some people like to use ISIS, but in this case, I'm using eBGP. I'm going to talk about that, how actually I designed this network, and you're going to see some details or recommendations and what do you need in order to design a network like this. And also, I'm going to talk about how you can configure multiple devices with GNMIc and Go Templates. GNMI is very popular in telemetry, but I'm not seeing many people using it for extracting information and setting information in the network. Then you're going to see that actually you can do that really fast. In my own experience, we did this also with netconf, and doing exactly the same changes on the network using netconf and GNMI. Surprisingly, netconf took about 2 minutes, GNMI took about 10 seconds. It was a big difference. Then I don't know if it's because of the proto buffers. I'm going to talk a little more about GNMI, how it's working. But you're going to see some of the scripting that I'm doing. And I'm going to give you some tips that you can use for ChatGPT if you want to create your own applications too. Okay? Just a disclaimer, doesn't mean that because I'm using ChatGPT, my company is using it. Okay? There are still many companies trying to understand the way that are going to take advantage of a resource like this. But I'm not suggesting to anyone here to use ChatGPT in your coding if it's going to be something sensitive for your company. Anyway, ChatGPT has a way that you can turn off the chat history, and then you don't need to send that data for training, because that can also expose anything that you're doing inside the company. Just be careful with that. There are some companies that are trying to do this internally with their own products, but I just wanted to give you this disclaimer because you need to be careful with using a tool like this, okay? When you are using ChatGPT, and I'm going to talk a little more later, I'm just putting an example here. You can do things, for example, asking, give me, please, a function. Well, you can say please or not. This is actually a machine. Give me a function, please, to sort out my, my array using a specific component, like I put in this example. And that was my first question that I did for to ChatGPT. I was trying very hard to create a function to sort my information that I was getting from GNMI. And then, surprisingly, there is a function that is native, is coming in the, it's a common function in Python that I can do this right away. And then save me a lot of time. Then things like this, for example, are very useful with a tool like this. I'm going to talk about that later. Okay, who is not familiar with GNMI? It's a protocol that is actually open source and is supported by Google. Was initially developed by Google. I think there are more people involved right now. It's based on RPC or gRPC. The idea is very efficient, versatile, and scalable. You can use the proto buffers to make to bring a really great performance when you are collecting information. It's very popular on telemetry. You can actually subscribe even from a command line using GNMIc to get information from many devices at the same time every 10 seconds. And I'm going to talk a little more about GNMIc later. But you can actually use also this with GNMIc to provide data and put data available for a platform like Prometheus that you can use later with Grafana. Okay? Something very important in GNMI is because it's using proto buffers, you can have a different language for the client and a different language for the server. They are actually proto buffers are the one that is the data that actually the format that is going over the network. Then in this example, I'm using SRL from Nokia. I don't know if they're using Python. I know the command line interface is using Python, but the client, for example, is in Go. Then there is no any dependency on the language that you are using for this case. Okay. I stole this slide from GNMIc for the last presentation of GNMIc here in Nanoc, and to show you that actually GNMI can give you, as a standard, can give you some operations like get the capabilities, is giving you information of the YAML elements that you have in a switch or in a router. You can use get to extract information, set to set up anything in the network, and you can use subscribe to get information every 10 seconds, 5 seconds, depending on what do you need. It's using gRPC as the main protocol underneath, but also is using HTTP2 to have multiple sessions in the same TCP connection. Then it's very efficient in that way. And I talked about the proto buffers, but something very important, a core part of GNMI is to use YAML in the devices. There are some devices that are using YAML as a first-class citizen in any box on any router or switch. In other cases, they are actually translating the information with an internal application, but the idea is you need the YAML in order to make it work. Okay? In this tutorial, I'm going to talk about two things. GNMIc, and I'm using GNMIc here to set any configuration on my devices, everything at once. GNMIc has a property that I can use Go templates. If you see the logo from GNMIc, it's very similar to Go, that actually is developed in Go. And you can use a YAML file as an input with all the variables to go and set anything that you need directly on the devices. I'm going to talk a little more about that in detail later. And also I'm going to talk about pyGNMI. That is, I use pyGNMI to extract information and manipulate information later, and because I wanted to display the information in something useful. In this case, try to find any misconfiguration on my network elements. Because in EVPN, you have many elements that you need to set in different locations. I wanted to try to sort this out in some way that it can be easy for me to identify there is a problem there. And also, pyGNMI, well, Python have libraries that you can use to extract some input from a YAML file. For example, I can set the credentials for GNMI and list all the routers and switches that I'm going to be touching with the get process in pyGNMI. GNMIc, I'm going to give an introduction of GNMIc. GNMIc is a command line application that you can run, I think, in any Linux. It's pretty easy to install. You have all the capabilities of GNMI directly on GNMIc, but also you can have other commands like a prompt that is going to help you to have a prompt directly in your terminal to be able to get recommendations over the way when you are trying to define what is the command that you are going to use to extract information from any device. You have generate, and I think generate is very useful. Every vendor had a different YAML model. Nokia have one, Cisco had something different, Arista have another different YAML design or YAML model. Then you can extract that from GitHub, and you can use generate to try to extract information directly from the switch or router and get this piece of information as a reference that you can use later to create your own files that you're going to use for all the rest of the configurations that you want to do in your network. Then it's a very useful, generate for me was very useful in this case to create, for example, my Go templates. I got that information, the piece of the information, and then I sort of transform those files into Go templates to later use that with many switches at once. And you also have a diff that is, you can use a router as a reference, get the information, it's going to show you what is the difference between all the routers that you had in your network with that router as a reference. Then it's not just the basic commands that you have from GNMI, you also can have another applications directly through a command line interface like this. GNMIc also is going to help you not just to work as a command line interface and put everything in the command line. You can actually use files to put and give some input for like variables, or you can, in this case, like I using for this tutorial, you can have Go templates to start forming what is going to be finally the configuration that you're going to actually apply on the switch or the router. Now I'm going to introduce pyGNMI. pyGNMI do exactly the same. There is not much different. It's giving you all the benefits from GNMI. However, because it's in Python, you can put this as a function, and you can extract that information and put it for example, this information in a dictionary, and you can start using that information later to sort it out in a table, or try to sort it out, for example, per EVPN instance or per router, whatever you're going to need. Then for me, it was much easier to go with pyGNMI to extract information and try to see, for example, if there is a misconfiguration on any of my routers. But for setting anything in my network, I felt, at least myself, that GNMIc was more simple to do that. ContainerLab, using ContainerLab in the way that you can create any use case, any topology that you need. You can just put everything in a topology file, in a YAML file. You can define, for example, the different types. You can have even different vendors on the same file, and you can define the way those vendors are going to be interconnected. The only heads up I can give you is, and this tutorial is available in GitHub. You can actually clone it and start playing right away if you want, is not all the devices are actually available as a native Docker image. Then in the case of SRL, Arista, for example, you have them and you can actually run those directly on your laptop. Or most of the cases, and many people is using a virtual server directly on the laptop to run this. But if you're gonna try with something else that is actually based on a virtual server, you need to wrap this into a container, like a QEMU process. But if you're gonna run into nested virtualization, for example, if you're using a VM in your laptop, then it's gonna be a little hard, or it's not gonna be a great experience. Then if you wanna do that, I recommend you to go and have your own bare metal server with a Linux in somewhere else. I have my own server in a lab, and that makes the things easier for me to run multiple instances of different routers. It doesn't matter if it's a native Docker image or is actually I'm wrapping this in a VM. If you go to the side of ContainerLab, they're going to give you the instructions how you can actually wrap any virtual image of any device that is in a VM or a QEMU file, how you can wrap this in a Docker image container and use that later through ContainerLab. Okay. Well, I'm gonna give some overview of EVPN-VXLAN. I think the presentation that we had before was really informative from the way that how BGP actually is working and everything with the autonomous systems and everything. I'm gonna talk a little more about that. But EVPN is something that is actually taking advantage of BGP in order to make your fabric more, to scale your fabric to more switches and have a better capacity and a better way to manage layer 2, layer 3 domains that can be extended through VXLAN, through that sort of tunnel technology. But basically this, I remember when I was working the first time with Fabrics, everything was layer 2. We have the problem with the spanning tree, and we were assigning VLANs for every tenant in the data center. And in some moment, we ran out of VLANs, and that was actually a big problem for us. I have everything actually in our spreadsheet. We tried to sort it out in some way, but I would say the VXLANs and EVPN actually make the things, the life easier for anyone that is actually managing a data center with a big scale of switches and routers. Here you have an example of many racks in the data center. You can spread or you can define multiple domains in different servers, compute nodes among the different racks on the different leaf switches. That is going to give you a lot of flexibility also. It's going to give you better link utilization, scalability. Also, I think there are some interesting things in multi-homing. I know I don't have too much experience in multi-homing, but I think it works really well. but you are going to have a problem probably trying to connect the underlay network with the overlay network, because EVPN-VXLAN is we call it like an overlay network, and you're going to have the underlay network where probably is going to be working with eBGP in order to interconnect the different elements. Then it's going to make the troubleshooting more complex, and also there is a learning curve for someone that doesn't have experience with this to start understanding the way that it's working and how you can actually take advantage of it. Okay. And the basics when you are designing a EVPN-VXLAN network is, well, you have the typical layer of spines or multiple layers of spines. You have the leaf. Every leaf requires a different autonomous, to be an autonomous system. You are using BGP, then in this case, it's working as an eBGP. And the idea is to communicate all the information of the interfaces and the loopback interfaces between all the elements in the fabric. Why you have a different autonomous system in every leaf is because it's going to give you, at least for the spines, they are going to have more information to forward any of the packets. Also, it's going to help you to control with policies how the traffic is going to go around. And also, I think the best thing of this is if you are adding or removing leaf from the fabric, it's not going to mess too much with the entropy of your fabric, of your network. Then there are many reasons that, because many people is using different autonomous systems in every leaf, and something's also separated for the spines. But in the case of the VPN, everything is going to actually be interconnected in the same autonomous system. In this case, what I have in this container lab, you can see the topology file later in detail in GitHub. I'm using a route reflector. And then this is a very typical case in customers that sometimes you don't want to stress too much the fabric or the elements in the fabric, keeping all that information about routes in the EVPN. Then you can use all the spines, or you can use another set of routers in order to have your route reflectors and create your autonomous system. And then all the sessions are going between the leaf and the spines. And then in every leaf, you are going to extend the layer 2, for example, layer 2 domain through a VXLAN tunnel with a specific VNI. Also, you have the option to add an Anycast gateway. I did that, for example, in case of when I have Kubernetes, make the things much easier for me to test anything on the network when I have a Anycast gateway. And also because I'm using the same topology to create some load balancer, layer 3 load balancer for Kubernetes on premises in this data center. How can start troubleshooting something like that? Well, there are many things that are going to require, first of all, I told you that you have the underlay with eBGP, you have the overlay with iBGP. Then there are some issues related. For example, if some of my interfaces are failing, I need to know how this is affecting or impacting any of my EVPN domains. But it's something very basic that is hard sometimes to troubleshoot is if I have many routers and I need to extend my EVPN domain through all the routers, I need to understand if I don't have any misconfiguration on all of them. Because in an EVPN, you need to define the EVPN ID, you need to define the route target, the route distinguisher, you need to define also the VXLAN ID and or the virtual network ID. Then there are many elements that you need in every domain, and they need to be the same in every leaf that you have in your fabric. And then To see this, well, when you had a couple of subnets, it's not going to be a big deal. But when you have a really big data center with so many tenants, so many clusters, start being can be a problem to try to go all over the switches manually and try to see is actually I have the same information in every one of them. Okay? Then this is the case that I'm working in this tutorial. To start working with this, you need to install Docker. It's part of the requirements that you have for containerlab. Containerlab is very easy to install. You just need to go to that link. I'm using that release because I didn't have time to test any new release of containerlab. And then you can clone directly that repo where I have my tutorial, and start creating your elements right away. Everything is based on SRL, using native container images, then it's not going to stress anything in your server with compute resources. You can also add other elements. In some of my labs, I'm adding also Prometheus, Grafana, GNMIc to start also doing telemetry of all the things that are happening in my lab. You can also add that kind of things directly on your topology. To create your lab, you can inspect your lab with this command, and then you're going to see all the elements that are in your lab. It's going to take just a couple of minutes to create everything. And then you can start checking on how everything is actually set. All the settings in this lab are also in the repo. Then as soon as you create the lab, you're going to see that actually I have the loopback interfaces, the eBGP actually is all working around, and the iBGP and EVPN actually are defined. Then you don't need to go and do that later. Everything actually is going to be there for you to start checking out and start modifying that and learning about this. Then in this lab, what I have in this repo, you have the loopback interfaces that I'm presenting here in this slide. Those are actual autonomous system numbers that I'm using in this lab. I had a border leaf that I'm not using. Well, no, actually, I'm using this border leaf too. But this border leaf, in the next tutorial for the next nano, I'm going to show how you can use it to control your load balancer using some hashing mechanism in ECMP directly on the fabric. But I'm going to let that for the next nano. So far, we are going to just troubleshoot the EVPN. And then you're going to see also in this lab that I have an autonomous system for the iBGP in the case of the EVPN, and I'm using those spines as a route reflector. All those settings are in the lab, and you can just download that, start containerlab, and you're going to see everything actually is set and start working. And you can start playing around with this. I created some EVPN domains. I have a layer 2, a layer 3 domain. You can see, well, I put the word cube because I'm using this with Kubernetes most of the time. But you're going to see that I have a MAC-VRF that is a layer 2 domain extended through VXLAN, and I have also a layer 3 between the three elements, the three leaves. You're going to see that they are also connected through VXLAN, and I'm using the client over here to start over there. Sorry, to start injecting traffic. Now, if you want to install pyGNMI, first you need Python 3. It's weird not to have Python 3 already in your Linux, then probably you already have it right now. And then you can use pip to install pyGNMI. It's going to take just 1 minute, and then you can install the rest of the requirements that I have for the applications. That is pyYAML to extract information from a YAML file, pretty table, and tabulate that I use to present information in a table directly on my terminal. And this maybe is going to be 2 or 3 minutes. To install GNMIc is very easy too. It's very similar to containerlab. You just go to the link, if you run that bash, you're going to have GNMIC, and then you're going to start testing this right away, like I'm doing here. Then in this tutorial, like I told you, I'm going to show two things. GNMIC working with Go Templates. And this, with GNMIC, I'm going to set some information directly in all devices at once. I'm going to create multiple layer 2 EVPN domains. Every domain is going to have a different EVPN ID, VNI, and also I can define any cast gateway if I need. And I'm going to use pyGNMI to extract information and present that information to see if there is any mixed configuration between all the domains that I have on all my switches at once. Okay? Then before to go there, how I did this with the ChatGPT. Well, first thing that I did is when I started to work with ChatGPT, I felt that it was way easier to start working with functions and classes. I wasn't prepared, or I didn't know so much about classes before that, but ChatGPT took the time to show me everything around that, to shape all my code and show me how can I turn something that I was working in my main function into a class and reuse that information later with multiple applications. Then as soon as I had the functions and classes, I can just copy and paste that part of the code directly on ChatGPT and start getting some fixing on bugs or getting information. For example, the error handlers was pretty easy with ChatGPT, and it's always taking a lot of time to put all that kind of stuff. Is something is failing, you want to get a message that is going to tell you what is happening. Then ChatGPT did that part for me, and then I didn't bother even creating any error handler in the Python. My recommendation is use always the same chat thread for anything that you are asking. When you are in the same function or you are in the same class, try to keep always everything in the same chat thread. That way, ChatGPT is going to get more context and it's going to give you more accurate responses. Do clear questions. Don't give questions. Don't leave the questions too open, because if you actually put garbage, you're going to get garbage. Okay. I have to be honest on that, but then try to be very clear with your questions and bring complete information, because with that, you're going to get also better answers. And don't use too much code as an input, because sometimes you're going, oh yeah, I'm going to get all my code, I'm going to put it in ChatGPT and see if they can do something better. Unless you're going to get some suggestions and high-level recommendations from ChatGPT about your code, don't do that, because it's not going to work as you are expecting. Then those are some of the queries that actually I did with ChatGPT. The first thing that I got when I was using GNMI client, I got a lot of information, and I didn't know what to do with that. And then I told ChatGPT, help me to put that in a array to make it easier to start working with it. And it did it. And it was pretty fast. Actually, it was copy and paste. Then another thing that I saw is I was doing many. When you're creating EVPN, sometimes you have in some place you need to define the information for your EVPN. In other place, you need to define your information for your tunnels. In another place, you need to define your route distinguisher and your route target. Then you have many different places. Then I have to go and extract information from many different paths. And I realized that actually I was doing almost the same thing in every path. And then I told ChatGPT, please give me a function that is going to make this much easier, that I can use with different paths. And then gave me a helper, a common function that I can use for all my queries with the pyGNMI. Other thing that I actually did is there is a function that can help me to create a dynamic table, because I was having a hard time trying to create a beautiful table on my terminal. And then when I asked that to ChatGPT, he gave me pretty table and tabulate like some sort of modules, Python modules that I can actually download and give me an example of how to use them. And that also make a big difference for me. Other thing is, when I created the table, I put that in the main function of the Python. I asked ChatGPT, can you take it please to like a function to make it easy to use in many times, and also did that. I got a very annoying message with the pyGNMI many times because I wasn't using certificates, and then ChatGPT told me how to turn off that message every time. Error handling was actually that was most of the things that I did with ChatGPT was create my error handling in my code. Then basically what I did is I took my code, I get into ChatGPT to ask some of my questions. In this case, I was trying to identify if there was any misconfiguration on all the information that I was getting from the switches. And then I told, okay, add the error handlers, and also I need to optimize this a little more. And I paste the code, enter, and you're done. I would say that actually when we were in the hackathon, we were also cheating with this in order to make it faster, because it made the things actually help you to work more on the algorithms, on the logic, and not bother yourself with the grammar or the syntax you can have on the code. That it is changing all the time, because in some cases I'm using Go, sometimes Python, sometimes I'm using templates, Jinja templates, and every time you need a different language to use, well, with this you don't need to bother about that anymore. And then I started to create the application with pyGNMI to list all the VRFs, get all the information, the EVPN information, VNI, EVPN ID, route distinguisher, route target. They were located in different places. Merge that information and present that information in something that I can actually read faster. Okay. And then when I started doing this, I did my main function in Python. I put that in ChatGPT, and ChatGPT recommended me to use a function. Then I use a function, and then it recommended me to use predicate table to display my information. And then when I did that, I created 2 different applications and told me, okay, you should create a class because you have too much, you are duplicating code in all the applications. And then I created a class and made the things actually way better. Then I created methods and everything that I actually didn't know so much about Python. Actually, everything resulted thanks to ChatGPT working really, really well. And then when I was working with class, I started to, I wanted to understand a little more about classes and actually give you an abstraction. I was getting information, for example, from my SRL devices, and I could create a class to bring some abstraction and give me, for example, for this specific device, I could create all those properties. And those properties even included some pyGNMI functions to get information and put it as part of the properties of the switch. It was pretty easy. And I could reuse this many times in many applications. And then I ended up with something like this. Then every time that I was creating a device, you can see down there, I have I'm creating an array of all the routers. That information, actually, I'm extracting that information from the YAML file. I created an array of different routers, and every router actually is a class. And pyGNMI is actually sorting all the information from the EVPN. A VPN directly has a property inside the same object. And then finally, I just need to address the object. I don't need to go to a specific path to put. I don't need to bother to understand where what I'm looking for. I just need to go to the device that is addressed like a class, and I have all the information directly as a property in that class. And this is, for example, a function inside a class that is called method. And I did this with GNMI. If you see here, this is the helper. Because I was going through GNMI, with the GNMI client, I was getting information from many places, and then I realized I was doing the same thing many times. And then ChatGPT helped me to create a common function for all those methods. And I put also all the input of my script in a YAML file. Why? Because I don't want to touch the code anymore. Every time that I'm changing anything in the topology, I'm adding more routers, or going to another data center, I have different spines or different leaf, I just can go modify my YAML file as an input, and the same script is going to work every time. And then this is a video of what I did. Then I'm using VC Studio. Then what I did is I took this application. In this case, this application is I'm listing everything per router at once. As you can see, I'm putting the data center nodes is my input file in YAML. And I create another application that is also sorting this information per domain, per EVPN domain. This is the basic information that you're going to have in this lab. As soon as you install the lab, you're going to see this right away. Okay? And now I wanted to start seeing how this is actually going to behave as I start doing changes. And then this is the YAML file that I'm actually using. Like I told you, you can modify the file, and it's going to work in any data center. With any with any sort of topology. And then and through GNMIc, also I started to use some interesting thing is ChatGPT recommended me to create constants. And with uppercase letters, I did that. Actually, it also looks better, you know, shaping my script with that. And you can see actually there are many error handlers in the middle. And actually I told him to put some comments too, to make it easy for anyone to understand what I have in the application. And I didn't have to even insert any comment in the code. I'm not saying you need to just copy and paste. You need to understand what are you copy and paste, but basically you're putting a little more time and making this better and not in solving basic problems with the syntax of the language. There you can see that actually I'm putting my path YAML junk path to extract information from any of the elements, and they are located in different places. And then I'm trying to sort this out in the same array using the class that I have there. And with this, I'm trying to highlight there is any mixed configuration between all the domains. That is something also very important, because if you have any type of, like in the EVPN ID or the VNI or the route distinguisher or route target, it's not going to work. Okay, then you need to be sure that everything have the same information. And then when you have hundreds of domains, it can be a trouble. And now what I'm going to do is I'm going to GNMIc. You see that actually I put some values there, like the VNI, EVPN ID, even the Anycast gateway that I'm going to use in every leaf. And then what I'm doing with GNMIc here, I'm inserting this information in all devices at once. I'm going to show a little more later of the GNMIc. I'm just using this as an example. It's that fast. You can just go and insert information directly on all devices. And then And I'm going to use the same pyGNMI script to see what have changed in my network. Then let's see. I think I'm gonna list that in per domain. Yeah. You see now, you can see that actually now I have many more domains than before in my network because I just did that with GNMIc. And it's giving me all the information at once from all the routers. And what I'm gonna do right now, I was testing my function that actually is going to identify there is any misconfiguration on my settings. Then I'm going to put a typo like this one. I'm change just the EVPN ID. And the idea is with pyGNMI, I can identify there was a misconfiguration. There is something that is not right in that specific domain. And then I could highlight that directly on my table. Then is very, I think it's a very basic example, but it's very powerful in the way that it can show you something that maybe you're doing right now, going to every router, every switch, every leaf, and checking the information and checking if there is a mixed configuration. It can be really easy to do with something like that. And you see that actually I highlighted this element, like there was a typo, in the table. Then now I know there is something that is not right on that domain. And I can go and change it. I use a pretty table tabulate. Again, that was recommended by ChatGPT. Worked perfectly. Tabulate is to highlight the things in the table. Pretty table is the format that I use to make a dynamic table for all the things that I'm showing there. And I'm using the YAML to extract information from a YAML file. Then I can reuse this script many times in many different topologies, many different data centers. Okay, now we are going to talk about GNMIc. And here, what I'm trying to do with GNMIc is to set some information directly on my network. Then I have, you saw that actually I have a YAML file with multiple information about different domains for different routers and switches. And then, but also I added some information like an anycast gateway, an IP address as an anycast gateway for my domains. Then the way this is working is, well, Go Templates, for who is familiar with Kubernetes or Jinja, is basically, you can use GNMI generate to get a piece of information from a switch. And then you can just modify some of the elements that can be taken directly from the YAML file as an input. Then, for example, if I have multiple network instances for the same router, in this case, I'm calling that a target, you can go over every network instance or every domain and setting all the elements that you're going to need in that network, like the VNI or the EVPN ID. Then you can reuse this many times. You can reuse this. Is very also you can separate the logic and the data very easily with those Go templates. And you can work with almost any complex format that you can have in your switch that can apply for any sort of switch that can apply for Cisco or Arista, SRL, for whatever. You just need to go and work with the format for every of the vendors. And then as an input, I'm also using a YAML. And if as a operator, you know that actually the information that I need to create a domain is very minimal. I need just the name. I need to set the EVPN ID, the VNI, and maybe the IP address of my anycast gateway, and that's it. I only need that information to go and set my domain. But when you go to the switch, you need to go through so many elements, to go and sort this out in some way. And letting the Go templates actually to do that magic, and only defining the minimal information that I'm going to need from my VNI, for my EVPN. And then the way that is working is I can go there, I'm showing a real template, Go template. The way it's working, all the paths that I'm touching with this in order to create my EVPN, how I created my route target, my route distinguisher, the ID of my VNI of my VXLAN, everything is in different locations, and I put in everything in the same file. And then I created another file that is called deletes, because like in Ansible, you go and create something, a playbook to create things, another playbook to delete those, also those things. It's going to make easier your operation. Then in this case, I'm creating all the elements. Then I'm using the same pyGNMI script to identify what I created. And now I'm going to go and use the Go templates that I did for delete all the elements too. And I'm going to apply those too. Something important, I'm also getting into the device to show you that actually this is working. Then I'm getting into my SRL device, and I'm going to show you actually all the information that I put in that file through, and then I use GNMIc, actually it's there up and running. Also, I had a experience working with Ansible. I know Ansible is very popular among what is network automation. But if you have all your elements working with GNMI, you should consider use something like that, because actually it's way simple to just go and maintain Jinja templates, roles, and modules, and try to create a very long playbook with many stuff. Working with something like GNMIc, for example, and create something like that, I would say that it's very straightforward. You don't need too much. You can just go and use exactly the same structure that you have in your switch and create your inputs in a YAML file, and you don't need to try to make or adapt any sort of playbook like in the case of Ansible. And it's very fast. Actually, I was impressed because I used to do this also with Ansible. It took me about 2 or 3 minutes. And with GNMIc, it's only seconds. This is only something, also a big difference. But now you can see that actually I deleted all the elements that I just created using the same GNMI, using the Go templates for that. And what I'm going to do right now is I'm going to add a new element that is the Anycast gateway, that is also in a specific interface, but I need to also attach that interface to my EVPN domain in order to make it work. And you see there, I'm creating this. And in order to make the Anycast gateway to work, I have to create also a layer 3 EVPN, or I have to attach all my layer 2 EVPNs directly to an existing layer 3 VPN in order to make it work. And then now my Anycast gateway is also working up and running in all my switches at once. This is the interface, and then you can see the information of the interface. Basically, this is the templates that I did for this tutorial. You can add or delete anything later. Everything is in the GitHub repo for you to start working or playing with it. And then in this session, what I showed to you is how to use containerlab to create a lab, to create a topology, spine leaf topology, where you can start exploring EVPN and how you can automate some of the operation of the VPN, like identifying misconfiguration in multiple domains. I show you how to use ChatGPT in order to create the scripting, how to use Go Templates and GNMIc in order to create things in your network, and how to use pyGNMI to also start sorting information that you are getting from your devices in something that can be more understandable for a human. Okay. There are some additional resources. There was a ChatGPT speaking session before here and I think it was really interesting to understand what is the potential. In that case, Mike, what he did is try to see if a ChatGPT can show some configuration for a specific vendors or model of switches or routers. And it was actually working well in some cases. I think it's worth it to check this out. There is also a ContainerLab a presentation in the same NANOC channel that Roman and Karim did online when we got a COVID time. And you can see also the GNMIc on the last NANOC. There was a complete tutorial that Karim did and you can see also how actually GNMIc can work and all the amount of features that you can use not just for creating things or extracting information, also for telemetry. Okay. Questions? Thank you. No? I think it wasn't so wrong with the picture there. Okay, thank you very much. There is a question over there. Go ahead.
I was curious if you tried GitHub Copilot with any of this?
Well, I know there is some people in the hackathon actually, they were using that. Not personally, but they feel that actually was very helpful. But when you need to go ask something a little more with more complexity, they switch to ChatGPT in order to make it work. But when you are coding and everything, it's pretty useful to see how this fixing the syntax and everything on the way. Very good. Okay. Thank you very much.